Good evening. Today we are going to see the moment of resistance, and that is for limit state method. Now we know for limit state method we have this is the strain diagram and stress diagram also we have seen in last video, and we have also calculated these distances which we have 3 by 7 xu and 4 by 7 xu. So this rectangle we have 3 by 7 and parabola we have 4 by 7 that we have calculated by considering these similar triangles. So now we will go for compressive force. So we have Cu that is equal to area of stress diagram into B. So area of stress diagram into B. Now what is area of stress diagram? So we have two part of this. One we have rectangle, another we have triangle. So we have that is equal to, so area of stress diagram. First I will consider a rectangle. So we have 0.45 FCK into 3/7 of XU plus parabola we have 2 by 3 into 0.45 FCK into 4 by 7 into 4 by 7. And if we will calculate this value, sorry, into multiply it by B. And then if we will calculate, we will get first value that is equal to 0.193 FCK into XU plus 0.171 FCK into XU. And then we will multiply by B. And if we solve this, we will get it as 0.364 FCK into XU. This is value of Cu. Now this will be considered, Cu will be considered as 0.36 FCK into XU. Now second we have Tu, which will act. So if I will consider this below, so it will act at the level of steel. So here, and that will be Tu, which will be equal to 0.87 Fy into AST. 0.87 Fy, so we have Fy upon gamma m, partial safety factor, Fy upon 1.15, so it comes 0.87 Fy. So stress into area, we will get value of Tu. Now we have to find out actually the position of this Cu. How we will find? So we will take x bar that is equal to summation of Ax bar divided by summation A. Now area already we have calculated, which we have 0.3 FCKXU. Now Ax bar. So we have value for rectangle, area we have 0.193 FCK into XU into. Now we are going to take moment about top. So we have from this. So we have center, we are taking moment about top. So we have this will be 1/2 into 3/7 of XU. So we have this will be into 1/2 into 3/7 of XU plus second part we have parabola, and that we have 0.171 FCK into XU into, now we will have this distance, that is, try to understand, this is most important. We have centroid of this is 3/8 of 4/7 of XU. So this is from this parabola, start of parabola. So from here centroid we have 3/8 of 4/7 of XU, and from top we have to add this distance. So if I will say this, so we are going to get this distance from top, and that is equal to 3/7 of XU plus 3/8 into 4/7 of XU. And then we can have this will be 2 and then 3/7 of XU plus 3 divided by 14th of XU. And if we will solve this, 6 plus 3, 9. So 9 by 14 XU we will get. So check it once. So 4 2s are, then we have to 6, 6 plus 3, 9, and we have 14 below. So 9 by 14 into XU. So we will take it as, or we can write it as 3/7 of XU plus 3/8 of 4/7 of XU. And then we have divided by summation A already we have calculated 0.36 FCK into XU. And if we will solve this X bar, then we will get this value as 0.416 XU. And then this will be considered as approximately 0.42 XU. So CU, compressive force, will act at 0.42 XU. Exact value we can write in bracket 0.416 XU. Now is it in a rectangle or in parabola? So now we can see we have diagram we have in this fashion. And then we have this length. This is 3/7 of XU. What is 3/7 of XU? So if you calculate 3/7 of XU is 0.429. And we have this as 0.416. So where we are going to get this value of compressive force. So your compressive force will act in a rectangle. You have rectangle till this. So in a rectangle you have CU, and this will act at 0.416 XU. So my CU is in a rectangular portion. This is most important because in oral you may have to face this question. So now we have this value. Now we will go to the neutral axis calculations. So now it is very clear. CU we have this value. So you can write below actually CU we have 0.36 FCK XU into B acts at 0.42 XU from top. So now we will go to the next part, that is neutral axis calculations. And we have neutral axis calculations. So neutral axis calculations we have simply by using CU is equal to TU. Now value of CU we have 0.36 FCK XU into B, and TU we have 0.87 FYAST. And from this we will get XU that is equal to 0.87 FYAST divided by 0.36 FCK into B, and from this we can calculate neutral axis. So this is neutral axis calculations. Now we will switch over to the moment of resistance. Now you can have this moment of resistance, and that will be Cu, which will act at 0.42 XU, and Tu, that is at the center of steel. Now this distance between Cu and Tu, so as this is 0.42 XU, and we have till this D, so automatically this is known as lever arm. And we have lever arm d minus 0.42 XU. And then we can write, so these two are parallel, equal in magnitude. So Cu and Tu are parallel. These two are equal in magnitude and opposite in direction, forms a couple which is known as moment of resistance, that is Mr, which is equal to Cu into lever arm equal to Tu into lever arm. Now Cu we have 0.36 FCKXU into B in bracket D minus 0.42 XU, that is equal to 0.87 FYAST in bracket D minus 0.42 XU. And from this we are going to get this value, that is of moment of resistance. So we have this as moment of resistance. And then we will see last part, that is balance section. So when we have balance section, when we are going to get both values satisfying simultaneously. So already we have seen this strain diagram, and from this we are going to calculate balance section, and then we can have by using similar triangles. So we have XU max, now I can say, so XU max divided by D upon XU max, and that is equal to, so this is XU max, relate with this we have 0.0035 divided by this value 0.002 plus Fy upon 1.15 into ES. And now we have dividendo. We will add numerator in denominator, and from this plus XU max, and that becomes 0.0035 divided by 0.002 plus 0.0035 plus Fy upon 1.15 is 0.87 upon ES. And from this we will get XU max upon D. This is also known as KU max, neutral axis factor, and that is equal to 0.0035 divided by 0.0055 plus 0.87 Fy upon 2 into 10 raised to 5, which is ES. And if you calculate this, then we will get it as 0.0035 into 2 into 10 raised to 5 divided by 0.0055 into 2 into 10 raised to 5 plus 0.87 Fy. So we have taken this 0.87 per 2 raised to 5 as LCM, and from this we will get 700 divided by 1100 plus 0.87 Fy. And this we have Ku max, that is equal to XU max upon D, which is equal to 700 upon 1100 plus 0.87 Fy. So this is most important formula, that is Ku max 700 divided by 1100 plus 0.87 Fy. So our value depends upon yield stress Fy. So these are the part actually which are related with your moment of resistance for limit state method. And now we will stop today here only. Remaining part we will see in the next lecture. Thank you.